Another simple example to understand the use of tree diagrams. Example 15. Jenny has a bag with 7 blue sweets and 3 red sweets. She picks a sweet at random from the bag, replaces it, and picks again at random. Draw a tree diagram to represent this situation and use it to calculate the probabilities that she picks 2 red sweets. Let's first organize a tree diagram. There are 2 colors in the bag, blue and red. So we have 2 options. Jenny has 2 options at the beginning of choosing the first sweet. So the first option will be blue and the second option will be red. And let's write down their probability values. So there are 7 and 3 together makes 10. So there are 10 in total, and out of 10 there are 7 blues. And this is the probability of selecting a blue for the first choice. And out of 10 there are 3 reds, so 3 over 10 is the probability value of choosing a red sweet for the first choice. Then after choosing the first sweet, she replaces it back into the bag and picks again another one. So let's continue to write down our selection. So after choosing, suppose that the first sweet was blue and she looks and see the color, put it back into the bag and choose another sweet. Again, we still have blues and reds in the bag. So Jenny has blue and red for the second choices. And also, suppose that the first choice was a red. She saw the color, put it back into the bag and choose another one, and from this option we have blues and reds in the bag, and their probability values are, there are still 10 sweets in total and 7 blues in it, so 7 over 10 is the probability value for B, and out of 10 there are 3 reds. The 3 over 10 is the probability value of red, and same values also for these branches. So we complete a tree diagram. Now let's find the probabilities wanted. Calculate the probabilities that she picks 2 red sweets. So where is the outcome? Let's try to find it from the tree diagram. Let's change the color. So I'm looking for red and red. So the first red, second red. Okay, follow the green branches. So this is red and red. So part A will be the product of these values. This is the value of the first red, 3 over 10, and this is the probability of the second red, same, and the answer is 9 over 100. In part B it says no red sweets. So when I follow the branches I see the outcomes. From this one I have blue and blue. From this way I have blue and red. From this way I have red, blue, and this way it is red and red. I'm looking for the choices where we don't have any red. I only have this case without red. Okay, so blue and blue is the wanted one now. So I'm going to multiply the probability values of the branches. So it is 49 over 100. In part C, we are looking for at least one blue sweet. At least one blue sweet means I may have one blue, or more. So here, which ones are the one desired outcomes that has this? Let's change another color. Let's choose purple. So I'm looking for at least one blue. So there is at least one blue. There is at least one blue. No blues here, so I don't need red and red. But I may have blues more than one. So blue and blue may be one of my desired outcomes. So I'm going to find the values of these labeled outcomes, then add them, because either this or the other one may happen. So probability blue and blue is already found. Probability blue red, let's calculate it. 7/10 times 3/10, 21/100. And let's calculate probability red and blue. It's 3/10 times 7/10. It's 21/100. Okay, as I said, these ones are desired outcomes. I'm going to add them to have the final answer. So when you add those three values, you'll reach 91/100. Actually, this is a one way of calculating this, but we have another way. There's a second way. Second way is taking away probability of red and red from 1, and you will reach the same answer. Okay, in part D, the last one, we are looking for one suite of each color. So I need one blue and one red. In choosing two suites, I need to see one blue color and one red color as an outcome. So I have two options here. I may have a red and blue together, or I may have a blue and red together. So probability values of these can be found by red and blue. We have already found this. Red and blue has 21/100. It's here. Blue and red, we have already calculated it in part C. It has 21/100, and either this or this may happen. So I add the values to have 42/100, and also simplify your answer, 21/50.